In this video, I am going to explain about what is the process management and introduction to this, what is process management and the importance of this. Okay, so let us discuss first what do you mean by this process. Okay, a process is nothing but a program under execution. Okay, so that means whichever the program which we are executing, that we call as a process. That means program under execution. So program under execution, or in simple word I can say running program. Running program is called what? Process. So process is running program or program under execution. So what it means? So we know that we use everything we are storing in the secondary memory, right? Assume we have stored some n number of songs. Assume some 50 songs we stored in the secondary memory. Now at a time, how many songs we are listening? So whenever we double click on any one song, that one song, whatever we double click, okay, that will be brought from the secondary memory to the main memory. And in the main memory, now once it brings to the main memory, our processor takes the instruction from that and keep executing. Now that means that one song is playing, remaining songs are not playing. No, remaining are still they are programmed, and the whichever the song we have playing, so that is CPU is executing that. That means this is the program, that is the file which is executing. That's what the program under execution. So that is what process. Remaining are program. Okay, so that's what whichever the program it is executing by the processor CPU, so that we call it as a process. So in simple word, a process is nothing but a program under execution. And in simple word, process is a running program. So okay, from now onwards, so process means a running program. That means program under execution. Okay, so remaining all are still it is in the what secondary memory, just simply the files or files will call, okay, or programs. So whichever we are executing right now, that is what process, right? And in the early days, so we are executing only one process at the same time. Okay, that means only one program is getting executing at the same time. Okay, since only one program is executing, the entire our computer resources are used by only by that one program. That means everything will be controlled by that only one program. So there is no problem for that operating system. It is easy for that operating system because what are all the resources our program needs? Our program needs main memory space, some secondary memory space, because initially we are storing in secondary memory. Okay, so then it needs some input device, it needs some output device, okay, and it needs CPU to execute. These are the resources. Okay, so resources means every program needs CPU to execute this. CPU time it needs some input device and output device, IO devices, some memory space in the main memory, and some secondary storage device, secondary storage. Okay, so that means the files it is. So these are the resources what every program requires. Since in the early days we are executing only one program at a time, the complete resources are controlled by that only one program, no problem at that time. But nowadays we are executing multiple programs at a time. That means we are doing multitasking, multi-programming. That means we are executing multiple processes at the same time. When multiple processes are executing at the same time, now all these resources has to share among these processes. Okay, because one process needs CPU time, at the same time another process needs some input device, at the same time another process needs some output device. So and every process should be in the main memory, and it needs some files which is stored in the secondary storage. So like this, so every process requires some resources, and now it is the responsibility of the operating system to provide all these resources whichever it is necessary, so that all these processes can complete the task efficiently. So now this is the task of the operating system. So there we need the concept of managing. What we need to manage? We need to manage all the processes. That means one process, whichever the one process should not affect others. Okay, that means one process holding the resources for a long time, making all other processes to wait. It should not make that. Okay, so our operating system should manage all the running processes. Okay, one thing. And whatever the resources, we are having only one CPU, we are having few number of input devices and few number of output devices, and only one RAM we are having, and one secondary storage, and these resources has to be shared among the running processes wisely by our operating system. That's what it has to manage these things. And whenever we are executing multiple processes, it has to create the process. Okay, it has to create the process, it has to terminate the process, it has to execute the process. So these are the tasks has to be done by our every operating system. So that is nothing but process management. Okay, as of now, we know what you mean by process and what we need to manage. That means we means operating system. What operating system has to manage with respect to the process, and what is this process management at an overview we discussed now. Okay, fine. Hope you people understood. Now let us go in detail about the concepts involved in the process. Okay. So now we know that generally whenever we are storing anything, we are storing everything in the secondary memory. There is the hard disk we are storing. In some drive we are storing, right? Assume we have stored some files we have stored. Okay. So we call files, programs, whatever. Okay. Now assume out of this, now we need to execute only one. All this now we'll call this programs. Whenever suppose if I want to execute this one particular file or program, now it has to be first brought into the main memory by our what? Operating system. Now it will brought. Okay, so now whenever we execute this program, double click on when we run that program, what happens? So it will get compiled and object files will be created, and those object files will be linked to one executable file, and that executable, its corresponding executable file also stored in the here only secondary memory. That exe file will be brought into what? Main memory by our operating system. Okay, now operating system brings the executable file of the program what we are executing into the main memory. Once it brought into the main memory, now CPU take this instruction by instruction and start executing. Okay, now when we write the program, how we write in the program like hash include, void main, all those things, it will be as it is, it will be stored in the program. But once it will be get compiled, so now the executable file, it is in a different format, right? So because all the object files are linked, what and all the references which we have, everything is reference will be resolved and it will be the bigger file than what we type. Because in our file, in our program, we have included so many functions, library functions, inbuilt functions, and the user-defined functions. So many, we have included some other files. Okay, so many things we did. So now everything is converted into one bigger executable file, and this is completely different. This will be different. Now that when that executable file, when we brought into the main memory, again it will be stored in a different way. Now it will be stored in this fashion. Now whenever any executable file will be brought into the main memory, so it will be stored as a separate, so code segment. Okay, so then data segment. Okay, so then we have heap segment, and then we have stack segment. So summary is, whenever a executable file of any program is brought into the main memory, it will be stored as a different segments. So every process in the main memory stored in this fashion, and this will be keep growing. Okay, it's not constant. Okay, keep growing this section. Now what this is, now this is nothing but we know that our stack, okay, all this heap is a data structure. Data structure is nothing but what? So how we are reading and how we are writing. Okay, that means organization of the data in an efficient way so that accessing will be easy. That is what the data structure. That means organizing means what? In the main memory, how we are storing. So in the main memory, how we are storing means that is the main memory, how we are storing in this fashion. Now, whatever we have written the executable file, so that will be splitted into separated into different sections. And this is called code segment section, data segment section, heap segment section, stack segment section. Now in code segment, what it will store, whatever the executable code we have written in the our program, that will be stored separately. Now this is completely in the binary. Okay, so now it will be complete executable file, executable statements will be stored separately as a code segment. Somebody will call this code segment also as a text segment. That means whatever, suppose for example, I have written some formulas. Okay, we have written some executable statements. Okay, that will be stored in the code segment. Then what is stored in the data section, data segment? In the data segment, whatever the variables we use, whatever the constants we use, that will be stored separately in the data. And here in the data, static variables, especially the static variables and global variables should be stored here. Okay, so here what will be stored? Global variables and static variables and some constant if you are using in our program, that will be stored separately in the data segment. Okay, next, what is stored in the heap segment? In the heap segment, if we used any of the dynamic memory allocation variables, dynamic memory allocation, so not dynamic memory allocation variable. So that means if for any of the variables, if we allocated the memory at the runtime, so that means using malloc, calloc, realloc or the new, okay, for such type of variables stored separately in the heap. Then what is stored in the stack? Suppose in every program we are using some functions. If we are passing any parameters, okay, if we are passing any parameters to the functions, okay, and then local variables of that particular functions, okay, and return value and return address, these are stored separately in the stack. Okay, now whatever we read the program, when it is the program is converted into executable file, in different format. One, that executable file will bring from secondary memory to the main memory. Now it is stored in this fashion in the main memory. Okay, so now our complete program executable file will be divided into different section. Code segment, which contains only the executable statements. Data segment contains only the global variables and the static variables and the constants what we use. And in heap segment, it contains only the variables for which we allocated memory at the runtime. That is dynamic memory allocation techniques data. That will be stored here. And in the stack, it is having the parameters what we passed and local variables, return value, return address of that particular stack. Okay, that particular function, that's stored separately. Okay, now you can ask me one question. Why we need to separate all these things? Let it be one, everything together. See, if it is everything together, now our CPU will take too much of time to distinguish between that. Okay, so for that, in order to make CPU task easy, in order to make execution faster, we are making this data separately. Dynamic memory allocated variable separately, global variable, static variable separately, and then local parameters, local variables, then return value, return address separately, like this. See, in our home, generally what we will do, we are keeping our every family member dresses separately. So we are not keeping the entire family member dresses at the one place. See, when we are in our home, okay, our parents' dresses, our dresses, our sibling dresses, we are not simply dumping at one place. What happens if you dump it at one place? Now picking or storing is may take too much of time. So that's why what we'll do, we store separately, our dress separate, our father dress separate, mother dress separate, like that we keep separately the dresses. Okay, at that time what? They can easily take. Similarly, again, our dresses also we are keeping like our daily wear dresses, okay, night wear dresses, party wear dresses, like that also we are keeping separately, so that what? Picking and as well as storing it will be easy. Similarly, if we divide our data or the code separately, then it is easy for CPU to take and execute. So that's why we are making separately. So summary, whenever the executable file will be moved from the main secondary memory into the main memory, in the main memory, our program will look like this. Okay, so we know what contains each one. Okay, now our operating system maintains the information about every process. Process means running program in another way. Okay, so it maintains one complete data about the process called process control block. Process control block, also called as PCB. It is also called as task control block. TCB, task control block. What it is contains, every process is having one ID called process ID, we call PID, and every process is there should be in one state. See, in the life cycle of every process, that means the time it becomes the process, once it brings to the main memory, till it completes, it has to be in any one of the 5 states. That we'll discuss, okay, later. Okay, so it should be in any one of the 5 states. So which state currently the process is in, okay, that will be the maintained. And what and all the CPU registers, so it uses. That means, because whenever our CPU brings some instructions or data, it has to store somewhere. So our CPU consisting of some special purpose registers and some general purpose registers. Out of 32 or 64 general purpose registers, which general purpose register allocated to this so and so process, okay, that it should maintain. And it should have program counter. That means, so whenever it is taking the instruction, which is the next instruction to be executed, that address stored separately in the program counter. And accounting information. Accounting information means, so this process created by whom? Who created? How long it will run? Then what and all the resources it takes? So everything. So IO devices, what and all allotted to this one. And memory limit. Okay. Memory limit means what? See, because whenever a process is created in the main memory, it look like this. That means if the data it stores from so and so area to so and so, it cannot simply take the data which belongs to some other process. So every process is having some limited memory is allocated in the main memory. So this process can take data only from so and so address to so and so address. It cannot take the data anywhere, or the data belongs to some other process, it cannot take. So that memory limit is there. So like that, all these information should maintain in one block. So that we call as a process control block. Okay, so this is every operating system maintains the information about the process in one block called process control block, which is also called as TCB, task control block. Okay, hope you people understood what you mean by process. Okay, and then what are all the resources every process requires, and what happens when we execute a program, and how that when the executable file is moved from secondary memory to the main memory, how it looks in the main memory, and how operating system maintains the information about the particular process, that we discussed. Okay, that is process control block that we discussed. Okay, if you have any questions, please write it in the comments. Thank you. Thanks for watching.